All right. We totally have 5 articles in this section. And I'm the chair, Zhong Zhao Hong from Taiwan. And I think the only guy from Taiwan. Only a few attend this Congress. I don't know, not popular in Taiwan, but maybe later on we will have more. And we have articles to present, 3 in online and 2 on site. And I think the first one, Mustafa is going to present the second one, is that right? Okay. He requested to be second one. And the last one will be the first one. Okay, great. Yeah. We have the last one. I call apply the text similarity measuring to detect plagiarism. Okay. But each chapter. So if you are ready, are you ready?
Yes.
Okay. So give hands to her.
Good afternoon, everybody. Can you see my screen? Can you see my screen on the computer? A little bit slowly. I don't know why. Very slow. When I connect to the yes. Okay, can I begin? Good afternoon, everybody. So my name is Thúy. The full name is Phạm Thị Thu Thúy. I come from Nha Trang University in Vietnam. I come to this conference and the first time I come to Thailand for a visit, so many interesting. So my presentation today is about applying the test similarity algorithm to detect the plagiarism for some kind in the for student. So my paper is about three sections. The first about the overviews of the measuring, and the second is to present the methods for vector model. It's in computer vision. And the last one is the software installation and test evaluation. So the motivation for this paper, because my major is computer engineering. So when I applied my paper to this conference, is a little bit different to the main purpose of this conference is in e-learning, but I think that it is so a little bit related to the education, because you know, when the student learning in the university, they using usually they copy in the text and some student idea from the other researcher is very the big problem nowadays. So our study to apply the vector model to detect the similarities of the text between this author to another. So this is our main contribution. So for the actually in nowadays there's some tool to detect the similarity between the documents, but in Vietnamese it's a different language because they use nowadays there are many tools that detect the English, the similarity between the English document, but for the Vietnamese language it's a little bit, so it's hard to text the similarity between documents. So our contribution is to find the best way to use some measurement to find the similarity between the document. And this is some researcher in Vietnam and some other researcher from another researcher from over the world about they find the text similarity between the document. So in our study we use the cousin similarity. The cousin similarity is the very famous one for measuring the angle between two tests. They said that if the angle between two test vectors is smaller, it means that they are very similar together. So we base on this cousin similarity to find the similarity between the tests. So after that we use another similarity is Euclid distance method. This is also used to measure the degrees of similarity. And if we will present the test by the vector to vector, and we use the Euclid distance to measure the distance between the vector. And if the degrees of similarity between two vectors is determined in this formula. So, and another, the third method is use the Manhattan distance, also famous one for measuring the text similarity between documents. Also, and the Levenstein is also the measuring the text with the between the word because in our document we have word by word, we have many words, so we can combine two words or three words together. This is used by Levenstein, and this is the image to display the short. What's more, this is some kinds of this is the Vietnamese work. For example, we have the figure 1 and figure 2. With the first one is the same. It means it's the same meaning, but they put some different word, just more than one word. But maybe it's if we measure you by the another tool, maybe it cannot determine. It said that it's different, but actually this is the same. This is the same if we use by the measure. Then our methodology is we use bondwise method to separate the Vietnamese words into the words and into every word, and we store in the vector. So we combine the cousin measure, the related one, to measure the semantic similarity between the word in the document. So the goal is to separate separate the text into the word and sentence. After that we use the bond-wide method, so we can improve the similarity between the word. And this is the screenshots of our program. We input the text of the word into the program, and we can get the result. In order to calculate the characteristic from the text, we carry out by some following steps. The step 1, we calculate the value, and the second we calculate the weight of the value. Because if the word is, for example, if the word is appear one time, it's okay. Maybe 2 or 3 or more times the weight increase. The more increase of the weight, the more similarity between the word and the document. So I think the weight is the weight of every word. So we calculate the weight of the word. And the step 5, we calculate the weight of sentence, because each sentence is combines of many words. So first of all, we compute the similarity between the word. After that, we compute the similarity between the sentence, each sentence, from each sentence to another sentence to another document. So we use this measure. In the step number 6, we use put in the matrix, because we use in the matrix the sentence and the text, because each sentence in this document to compare each sentence in the whole another document. For example, in the first document we have 10 sentences, and the second document we have 20 sentences. So we have to compare one sentence to each of 20 sentences of another document. So we have to put in the matrix each word to compare other word, or each sentence to compare to other sentences of the second document. So that's why it's use the matrix. So the step 7 we use after we had the similarity between the two matrices. So we calculate the similarity between the document, between two documents. In general, I can make in short sentences. First of all, in order to compare the similarity between two documents, first of all, we separate each word in one document into one word. So we compare the word to another, to compare the similarity between the word. How many words is the same, and we make it in a weight, weight. And after that, we compare the sentences similarity between document. This sentence is what is same with another in the document. So after that, we calculate, compute all the sentences in the document. We have the result. The final result is the similarity between two documents. So we use the data we use in our research. We use the paper in our university, because in the Naval Academy, in Naval Academies, in our country, we have two kinds of university. Also, in Nha Trang University is a public university. On of our paper, when we publish our paper to outside, so you can go to internet to find our paper. It's okay. But for the Naval Academy, it's mean in the police or some security, outside cannot find this paper. We cannot find our paper in the Naval Academy. But how to when another people in this academy or other people want to apply the paper, and how to find the similarity, the plagiarism between the reverse paper to another paper. So we had this method very, very important. We use this we use this data set and to test for our university. So the result is this is the first one we use the first for about 600 works to check the similarity between the three methods: Cousin, Levingston, and Chaka, and we have the result. That's a little bit small. And for the three methods, we can reach a conclusion like this. The Cousin method is the right is they compute in the order of the word. For the Cousin method, in order to compute the similarity between the word, they compute the order. For example, go before or before go, it's in different. It's in the order of the word. So maybe, but in Vietnam, when we move the word, maybe it's the same meaning, but when they change, it is the Cousin method said that it is different, so it's not good. So Cousin is based on the order of the word in the document. And the second, for the Cousin method is similar if the author copy the same text and they put in the document, we can easily define this. But if they change the order of the word, it cannot find. This is the main characteristics of the Cousin method. For the Chaka method, based on the number of common words, it means for two sentences. So there are some sentences, they have some word. If the word is they are so similar, they said that it is the common. It means it appears many times. So if it appears many times, it means the higher similarity. For the Levingston method, it has the more advanced than another two methods. And the processing speed of the Levingston method is higher than Cousin and the Chaka method. But for the Cousin method, they also have some advantages. They show the problems of text indexing. We use the text indexing because we separate the text in the word. And the Cousin is very easy to understand and easy to install in the computer by a program. In our paper, Roman, we can apply the Cousin measure to combine the measuring method and other method, and to find in order to improve the accuracy of the similarity between the word. So in the future is we can test for another paper, another data set, because in compare to find the similarity between the word is it depends on the data set. But if the data set is very large, and the speed of the RAM is very slow, because for example, if we have 20 documents, we compare one document to 20 is okay. But if we compare one document to 200 documents in the data set, is the problem. Because the more data set, the larger data set, the lower speed the RAM. So that's what is the main. So we had to make some the algorithm is very speed as possible. Yes, yeah. Yeah. So thank you for attention. I finished. Yeah.
Speak loudly. All right. Thank you. Any comment or suggestion to this article? You know, I just like to ask. To myself, I use the school university offer like 30 in. That's what my university use. Then I just put it on what I should select which one. You have cosine. Also, you have different system to check the similarity, right? In your school.
No, in our school, it means I use the data set in our school. It's the paper in the journal of our university. The data set is the journal, the paper
yes,
within our university. Because you know, in Vietnamese we have possible my university, Nha Trang University is okay. Our paper is public, is area.
Okay.
Outside can see, but the naval academy is cannot see, so we use the.
Okay, that's a closed system, not open system.
Yes, or in our paper in naval academies is a closed system.
Okay.
Yes,
Right.
other cannot find. Yes.
Okay. Any question about this article? Yes.
Okay, thank you for your interesting presentation. I have some question about your method in evaluation step because I don't familiar with this task. If we say about supervised learning, we can evaluate that task in the number, just like accuracy, F1 score, or either. But in this task, take similarity, how you evaluate them. I'm sorry if I lost some point, but I want to know how to evaluate accuracy of your tools that you create.
Yes, this is a very interesting question because usually this is one of the supervised machine learning. And the next step of this study, we had to evaluate the similarity between the tests. Actually, we already measure the similarity between the tests, but I didn't put it in the the accuracy and the F measure or record. If this is necessary, but this is in we already used the similar between some methods is Cousin, Levinson, and some other research. In order to use it, we had to have the sample data set and the test data set, so we can use the test to can the value of the recall, F measure, and some other comparison result with another method.
Okay, how many percentage can be accept similarity?
In our for example in our data set is some
That depends on department or depends on school. There's some department only 10% similarity can be accepted.
No, the similarity between the accuracy for the accuracy of our method is better than the Cousin method and the Levinson, because this is the already people already update, but we use we based on 3 methods and we put some another improvement. We made some another improvement, so our advantage is better. Is for example the value is about 0.7 or 0.8, 0.5. Usually when we have some about 0.8 or 0.9, this is a little bit higher. Accurate, more accurate than.
Okay, 18%.
Yes.
Okay, thank you. All right. we go for next one. Can we? Okay. The number 62, that will be online, is that right? Okay, so we have a hybrid clustering learning models based on the self-regulated learning model used unsupervised learning by majority voting technique. That present online.
Can you see my presentation?
Okay, I can see your head. All right, we see your PPT.
Good afternoon. I amญญาอน from University of Payao, Thailand. Today I would like to present about hybrid clustering learning models based on self-regulated learning model using unsupervised learning by majority voting technique. Let me start with introduction, research objective, and then material and methods. Move on to after that, I would like to talk about research results. Move on to discussion and then finally conclusion. Now let's start with the introduction. The impetus of technological advancements has resulted in a sudden change in the learning pattern and learning style. It has changed the learning achievement model, and the learning style is not limited to the classroom. Additionally, the impact of COVID-19 pandemic has transformed learning and catalyzes the transition from formal education learning into informal and non-formal education. When modern technology and the epidemic accelerates the transformation of learning pattern. As a result, learners, educators, and educational institutions must adapt to the changing life trend in the post-COVID-19 era. The changing learning style also requires research to find reinvigorated learning style fitting for learner learning outcomes. However, online learner has been mindful of the impact and degradation of learning performance, such as ADHD, being distracted by auto stimuli, and lack of self-control during learning. The basic principle of organizing the learning process to develop learner is to find a group of learning behavior for determining group learner cognitive development characteristics. Considerable number of researchers have concocted awareness and open space for learner development with technology alike with individual learner learning potential. Using machine learning, it has required researchers to develop a learner clustering process that generally correspond to the behavior and potential of the learner. Move on to research objective. This research has three main processes. The first objective was to study the context of learner learning achievement based on self-regulated learning style in higher education, and to contrast the clustering model based on self-regulated learning style by majority voting technique, and to propose optimized clustering method for learner achievement based on self-regulated learning style. Material and methods. The operation and activity We use 42 students enrolled in the course Business Analytics at the School of Information Technology and Communication Technology, the University of Payao, during the second semester for academic year 2022. Three main objectives were 24 quick assignment, midterm and final exam. The 24 quick assignments were divided into two sections of 8 chapters. It was pre-midterm and post-midterm activity. Next, go to data collection. The data collection was a record of score the accurate according to the three main objectives based on the self-regulated learning principle. It was designed for this research. The instructor assigned learner to set goal for each activity. Therefore, the feature consists of 25 attributes from 7 categories. There are sets of goals for each activity, score for each activity, goal for the midterm exam, score for the midterm exam, goal for the final exam, score for the final exam, and student academic results or grade. This table shows the data collection are summarized. It shows the maximum, minimum, mean, and standard deviation score and time they use. The research were selected appropriate consistent with the model developed process for clustering learning outcome based on the self-regulated learning model. It was composed of 6 steps. Step 1, establish and determine of k-value for the optimal number of clusters. We use K-mean, and X-mean clustering technique. Step 2, determine the k-value by the elbow technique. And next, voting for a consensus of k-value used to define the sum number of clusters. Step 4, specify which cluster is record belong of for each technique. Step 5, decide on a majority vote from the affiliated cluster members for each record and assign a new cluster to member. And final step, consider and compare the data behavior of member from each technique. This research used 3 unsupervised learning techniques to compare the voting score. Subsequently, use K-mean, and X-mean. Research results. This table presents summarize the analysis result of k-value change for each of the 3 unsupervised learning. As shown in the average bit in centroid called ACD, where the appropriate K for the K-mean method is K equal to 4, 5, 6, and 7. For K is K equal to 4 and 5, and k-value for x-mean is k equal to 4 and 6. from the method set in step 3, it can be concluded that the reasonable k-value to be used are k-value of 4. This table presents the number of number in each cluster classified by each technique. And then the design to next step. This table shows analyze result of the member based on the majority voting result. Data and voting summarized is in the researcher design summarized for the number of member in each cluster. In addition, the cluster refer learning outcome or grade to compare the learning behavior of the learner style. Move on to discussion. This research optimize the number cluster form K-mean, K-mean, and X-mean clustering by the arrow technique. Researcher found the K equal to 4 that were appropriate for the clustering model produce accuracy. Researchers found the member of cluster 0 score the activity post-test of 2, 3, 4, and 9 variables, which show similar self-regulated learning style. Therefore, some member is included in cluster 2 score equal to 0 from 50% of all members in the activity post-test of 4, 6, and 11. The question is why they did not understand or do it better. The answer may be that they do not like self-regulated learning style. The score of the activity post-test 6, 7, 8, 9, and 10 of member cluster 3 has a little bit scattered value. They show slight difference in their knowledge of this activity. And the experimental result member of cluster 1, cluster 2, and cluster 3 are consistent rate. It offers similar self-regulated learning style. The member of clusters 0 like the same activity. It can be concluded that they have good grade and satisfactory grade. And finally, conclusion. This study investigates the use of unsupervised learning for clustering learning outcome based on self-regulated learning and online learning behavior. The researcher proposed method utilize a combination of K-mean, K-mean, and X-mean clustering algorithm and ensemble majority voting technique to identify the optimal number of cluster and predict learning outcomes. And the result of the study show that the proposed method is effective in predicting learning outcome based on self-regulated learning and online learning behavior with high accuracy. And the results show that the deciding on the appropriate number of clusters was reasonable. The study has some limitations, such as the focus on a specific group of students and limited number of attributes used for clustering. Therefore, future research is necessary to validate the proposed method in other educational contexts with a larger number of activities. Thank you for your attention.
Okay, thank you for the presentation. Any question about this topic? You know, I do. Okay, you have one. Okay, go ahead.
Hello. So I have a question. When you, I don't know whether I'm missing something or not, but can you explain more about what do you mean by self-regulated learning? Hello.
Okay. The self-regulated learning is a theory of education. They propose the idea that students have to set the goal, and then students try to do something that to get the goal. If they have the goal, they will get react from the teacher, like a score, like something like that. If they fail in the score, they have to try and try again to get the goal. That's the concept of the self-regulated learning. That's it.
Okay.
Okay, it's an interesting topic, and I like to know airball point in different learning style, different shape-regulated learning style, and if you draw the airball point or the K value, but airball point, like we can find which style is different from another style. So that's I think the airball point is very important to let people have some visual thinking about your study. Instead of just those figures, you can draw some kind of like a slow line. Then people know what is the airball point. And to myself, I think regular learning style is very few to hear this kind of study style. Or we call strategy, SRL strategy.
Yeah. Yes.
So not a style, and the strategy basically can divide three phases. Plan, execution, and evaluation. And that's a style maybe talk about some people like to plan but don't like to execution and don't like to evaluate something.
Yes.
So that's called style. I'm not quite sure if the people have some kind of tendency to practice SRL in planning, execution, and evaluation. So that's if that's what you call name style. So you had a better present what people tendency about style. So this can make people understand your what you studied. Okay, do you know what I'm suggesting?
Yes, thank you.
You are from Vietnam. Okay, very good job. All right, another question for this paper? If not, then hope some other day you can do better and publish better. And see you in Thailand or see you in Taiwan. Okay. All right. We go to next. That will be online too. Comparative research on online teaching behavior based on data mining. Okay. G Fun. Okay. From China or from there?
Yes.
Beijing Language Cultural University. Okay.
Okay, thank you. Good afternoon, I'm from Zita. I come from Beijing Language and Culture University, and my reported topic is the comparative research on online teaching behavior based on data meaning. In 2019, 11 departments, including the Chinese Ministry of Education, jointly issued the guidance on promoting the healthy development of online education, emphasizing that online education is an important part of education services. we should have clear recognition of the current state of online teaching. The research uses sequential analysis method to explore the interrelationship between online teaching events and to improve the effectiveness of online teaching. There are some studies on sequential analysis. Studies proposed sequential analysis in 1978, which was used to test whether there was a statistically significant probability of one behavior occurring after another in teaching. Lishaw et al. Collected course learning data over 2,000 students in model platform and used correlation analysis, sequential analysis and cluster analysis to conduct the study of online learning behaviors frequencies and participation patterns. Yang et al. Used the LSA method to compare the differences in teaching decision-making behavior between novice and pro teachers. Based on some research and documents, we found that there have been research focused on online teaching, use LSA method, and we want to distinct different teacher group to find what are the significant serious characteristics of novice teachers and mature teachers in online teaching, and how can we intervene to improve the effectiveness of online teaching. This research uses LSA to explore significant behavioral sequences in online teaching interactions. The study used the LSA software, GSEQ, which jointly designed by Bateman and Kuro to efficiently process the data. Conducting sequential analysis mainly includes the following steps. The first is determining research questions and designing behavior coding tables around the research questions. The second is collect classroom teaching behavior data according to the behavior code table. Then input the teaching behavior data used in the research into GSEQ software for LSA. Generate a behavior conversion frequency table and an adjusted residual table and draws the behavior conversion graphs. And the last step is the interpreting behavioral sequence relationships in response to research questions. This research selected 10 international Chinese online course videos from 5 novice teachers and 5 mature teachers as research samples. The research is based on the OKC software, which is developed by Professor Zhang Hai, and a framework of CETDNA developed by Zhang Hai for data collection as shown in Table 1. Considering that in addition to the coding table dimension, OKC software also includes 2 dimensions, complete media and non-media. These are included in classroom teaching behavior coding. Now let's see the results. Encode classroom teaching videos based on framework to ensure the reliability and validity of work encoding. A coder first encoded the classroom teaching video, collecting a total over 8,000 sample data. Use the GSEQ software to analyze simply generate a behavioral sequence, the frequency table, and if they score over 148, 19.6, it indicates that the behavior sequence has statistically significant. Based on the adjusted residual table, we draw the online teaching behavior patterns of different teacher groups as shown in Figure 1 and Figure 2. Now, the analysis of significant behavior sequence in online teaching, we found that novice teachers tend to have shallow conversation with the students, while mature teachers are good at asking in-depth questions. Novice teachers often encourage, interact, promote, explain, and pursue students' speeches after questioning, ultimately forming a questioning loop. It should be noted that the interaction level between novice teachers and the students is often at a low level, and students' responses are mostly manifested as mechanical responses, equal responses, and so on, lacking deep thinking. Compared to novice teachers, mature teachers are more able to consciously guide students to conduct speeches and ask more open-ended questions. After the mature teacher asks a question, a short period of silence or confusion is a noteworthy sequence of behavior. It is noteworthy that there are almost no students centered online learning activities, such as the student collaboration, independent use of educational resources, and creation of work in the two types of teacher behavior sequences. And the teaching with the instruction is more obvious. We also found that novice teachers are proficient in single technologies, and mature teachers are able to use the multiple technologies to teach. The behavior sequence reflects that mature teachers' continuous meaning debugging behavior is more significant, while novice teachers have less continuous media debugging behavior in their classrooms, indicating that novice teachers have a more proficient mastery of technology. However, compared to novice teachers, mature teachers use composite media more frequently and continuously, reflecting their ability to adopt flexible and diverse technological methods for online teaching. In addition, the continuous use of narrative media with ICT sequences by both types of teachers in the classroom was significant, and the main instructional behavior corresponding to this sequence was teacher gave explanation. Among the two types of teachers' TPAC structures, TCK and TPAC appear most frequently. TCK mainly corresponds to teacher controlled behavior and teacher-student controlled behavior at the same time. Based on the adjusted residual table, it was found that novice teachers' PK and TPACK sequences formed by reactional flow. The continuous mature teachers' TPAC sequence was particularly significant, revealing that mature teachers are able to effectively integrate content knowledge, pedagogical knowledge, and technological knowledge to enhance teaching efficiency. There are some optimization strategies to enhance teachers' online online effectiveness, online teaching effectiveness. The first one is the learning science perspectives, reinforcement and breakthrough for learning subjects. Research in learning science has confirmed that passive learning, active learning, constructive learning, interactive learning is the evolutionary change, and that interactive learning works best. Analysis of data reveals that the online classrooms of both types of teachers behave conservatively, lacking student-oriented learning activities such as hands-on inquiry and group cooperation, and are more dominantly by teacher explanation and questioning. Teachers need to develop inquiry-based, project-based, and collaborative online learning activities to activate students' sense of agency and active learning. The second is technology integration, perspective, innovation, and transformation of teaching media. Through data analysis, it was found that teaching media is more used to support teachers' teaching and less to support students' learning. Teachers should be proficient in digital education platforms and information exchange tools, and so on. They should use a variety of technological tools to create open, flexible, and free learning interaction systems for students. Collect learner, process data, realize personalities, resource recommendations, and learning feedback, and achieve innovative changes in the teaching mode empowered by technology. The third is teacher development perspective, construction and improvement of training mechanisms. Data reflects teachers' digital literacy needs to be improved, and it is urgent to build and improve teacher training mechanisms. Building online teaching resource platforms to provide teachers with scientific digital teaching tools, operational training courses, and teaching application cases to help teachers update their knowledge structure and solve practical problems in real syllabus. Based on the National Smart Education Training Platform, collecting process data of teacher training, monitoring data of teachers at different training stages, currently promoting online resources, typical cases, and comprehensively improve teachers' digital competence. The last part is conclusion. The application of as a method in online classroom teaching behavior analysis provides a strong basis for teachers to perspective the classroom behavior, deepen reflection, and improve teaching in future research. Like sequential analysis method can also be used to compare the teaching behavior of different teachers and course types, and to analysis students' learning behavior, thus providing a scientific basis for improving the quality and the effectiveness of teaching. Okay, these are the things. Okay, thank you for your attention.
Okay, very interesting paper. Any question? All right. Okay, microphone.
Okay, thank you very much for your presentation. Sorry I didn't catch your name. I'm very interested with the sequential analysis that you're doing. I just would like to know how did you establish the reliability of your analysis? So when you code your videos, I assume you code that using the table of the framework that you have, and then you put the codes on that, and then you calculate the sequence. May I know how did you establish the reliability of your coding? That's all.
Okay. Thank you for your question. This research based on the coding table. They say this coding table developed by Zhang Hai, professor. He is a professor in Western Normal University, and his group developed one software, OKC, and this table, according the as coding, and I use this coding table to recording some behavior in the online classroom. You can find this coding table from the research. For example, from Zhang Hai professor group, there have some introduced for this table, how it establish this table, and it more authentic. Okay, thank you.
Okay, I think it's you want to.
Thank you for your answer. Maybe I don't know whether you're an academician or a PhD student. Maybe I can just add to your answers. What you can do when you analyze or when you code your video data is that you can appoint another rater to rate. So when you independently code, you watch the video and then you code the behavior using the coding scheme. What you can do is that you can appoint another coder, give a sample of videos, and then ask another person to also code that video independently, and then you can compare the both of the coded videos and then calculate for inter-rater reliability. So then I think it can give an added value to your research, in which that when you code that video, it has it's not just based on your own perception of analyzing the data. There's also someone else who also coded the same way and the same way like you do. This is what I mean when I ask you about the reliability of your coding when you analyze the video, the teacher's video using the coding scheme. Maybe I think you can read that somewhere. I think it will definitely help you with to make it a more solid for your paper. It's a good presentation. Thank you.
Thank you.
Thank you.
All right. I think one suggestion at the end of your presentation, you give too many over suggestions. Your suggestion should based on your research result, not from something else. Okay. And the other one is very interesting. Talking LAS, sequential LSA. Most people think about LASA should be time sequence and some kind of events, first event, second events, third events. But I think you are trying to use content knowledge, pedagogy knowledge, or something else, and to check maybe not like time sequential. So it's okay. I think you can use it, but you should show what's the difference based on the research. And talking about novice versus expert teachers, I think the other now in the classroom, I don't know if too many interaction from the expert teachers, then how is the learning process for the students? If some students they get used to the kind of teacher just talk about content, not too many so-called pedagogic content teaching method. So then just some kind of other study or feature study, you can try to figure out what's different and draw a table, compare novice and expert teacher, and then people will know what's different in terms time sequential. You give a figure, two figures to compare, but you need tell us what's different from those two tables. Now two figures. So if you can show the difference, maybe people think that difference is different on content knowledge or on pedagogical knowledge or TPHK. Then that will be more attractable to audience. You know what I'm talking about?
You see this
Oh yeah,
pictures?
these two figures, and if you can tell the difference, novice to experts, and expert have some kind of not only content knowledge, but he teach what because from these two figures we cannot we see more interaction, but interaction is in terms of pedagogical content or what kind of content or use ICT.
Yes. Yes, I pulling from behavior and media and the TPAC, and find some difference between novice teacher and the mature teacher. I think I need to research further between the two groups, teachers difference, and I think in the future I can add the competence teacher and compare the novice teacher, competence teacher, mature teacher difference, let's say online teaching. Thank you.
All right, I think future if maybe make more elaboration about these three figures. Other two people just say we can figure out the different in the bottom part, but we cannot figure out what's too much different and what the difference belong because that what kind of knowledge, pedagogical knowledge or content knowledge or TPHK, something like that. All right, thank you. Hope you can publish a good paper. All right.
Thank you.
All right. And other question about these articles? No. And we will move to next one. Seems the last one. Okay. So, empowering higher education. We cannot hear you. All right.
เจมส์ครับว่าเจมส์ครับ
Sorry, we have some trouble here.
Can you start this, say something? What?
Sorry, please wait a minute.
Okay. Go ahead.
เจมส์พูดกันไม่ทัน
You share your PPT, is that right?
I'm trying to share my screen. Please wait a minute.
.有一个分享键，在下面一行里面有一个分享键，你应该可以。OK, here we are.
Okay. Good afternoon, everyone. Thank you to the host and organizer of the International Conference on Smart Learning Environment. I appreciate the opportunity to present this presentation online. My name is Gao Xiaoxu. My team members are Rong Qian, Kong Weiru, and Xiao Yujie. Our major is educational technology, and we come from Northwest Normal University. Today, the topic of my presentation is empowering higher education, a review of AI integration. My presentation will include 6 parts: introduction, research questions, literature review, method, discussion, and conclusion. Let's start with the background. AI is a growing field in computer science with advice in reliable and accuracy, especially in language translation and facial recognition. It's changing industries like manufacturing and transportation and becoming a key topic in education. While there is extensive explosion of AI in basic education, Chinese universities are just starting to study AI empowerment in education. This study examines the changes of AI in higher education and proposed solutions. In order to develop more comprehensive into the application of AI within the realm of higher education, the research question of this study focuses on question 1. What are the research methods used in AI-empowered higher education studies? Question 2. What are the research themes in AI-empowered higher education studies? Question 3. What are the key challenges and barriers to implementing AI technologies in higher education? To clarify the overall landscape of AI in higher education application research, to understand its inherent evolution logic and inner mathematics, this study implied a systematic literature review approach. By examining and synthesizing articles from the past decade, we aim to provide a comprehensive overview of the progression and intricacies of AI research within the domain of higher education. This study reviewed AI research in higher education using databases like Web of Science, Springer, and Science Direct. Searches were conducted using the following search term: artificial intelligence, or machine learning, or deep learning, or nature language processing, or learning analytic, or adaptive learning, or intelligent tutoring system, or student modeling, or personalized learning, or collaborative learning, and higher education in the title, abstract, and keywords. The literature was intently revived from various databases, yielding a total of 160 articles, 97 from Web of Science, 37 from Springer, and 26 from Science Direct. The collaborative screen was undertaken by 4 researchers from this study, following a 2-phase progress. In the first phase, the researchers independently revived the literature, titles, keywords, and abstracts, which results in a perception of 135 articles. In the subsequent phase, the researchers convened to discuss their individual findings, resolve discrepancies, and reach a consensus. This led to the final inclusion of 95 articles. This method ensured both independent judgment and collective validation and of the selected lecture. If you look at this picture, you can see it shows that the highest number of publications occurred in 2017, 2018, and 2020, highlighting the AI's prominence in higher education during that period. Figure 3 shows us the research method used in AI-empowered higher education studies. The majority of studies use quantitative method, indicating an interest in measuring AI's impact with manual data. Qualitative method comprise 30% of the study. Mixed method account for 20%. Emphasizing a comprehensive understanding, and computational technology account for 5%, reflecting a growing interest in advanced data analysis in employing AI's roles in higher education. The dominance of quantitative method. The widespread use of quantitative method in AI-empowered higher education studies highlights a preference for data-driven results, reflecting the fleet maturity with well-established benchmarkers. The value of qualitative insight employing qualitative method emphasize the importance of deeper understanding in AI's roles in higher education, particularly concerning human experience and perceptions. Rest of mixed method. The adoption of mixed method represents an in-value research trend that combines data with contextual understanding, offering a comprehensive review of AI influence. Emergence of data-driven techniques. The uptake of computation technology suggests an increasing interest in harnessing advanced data analytics for research as educational AI systems become more data-intensive. Figure 4 shows us the research themes in AI-empowered higher education studies. The main focus include personalized learning, emphasize AI's ability to individualize education, and the intelligent tutoring system account for 24%, showcasing AI-powered tutors. Learning analysis and data-driven decision-making account for 20%. AI's impact on curriculum design account for 8%. and the ethical, legal, and the social implication of AI account for 20%, highlighting the challenges and the need for response implementation. Artificial intelligence technology has potential to benefit higher education institutions in various ways, but is not without its challenges. To successfully implement AI technologies, institutions need to address several key challenges and find effective solutions to overcome them. Ensuring data privacy and security, secure data management. The extensive use of data in AI systems increase privacy and security concerns. Higher education institutions must implement secure data management policy to ensure that student data remains confidential. Pedagogical integration. Integrating AI in higher education requires a shift in pedagogical approaches. Institutions need to provide proper training to educators to incorporate AI into teaching strategies and curriculum successfully. Budget constraints. AI employment can be expensive, but most institutions face budget constraints that limit their ability to investigate in AI technologies. Institutions need to consider the cost and benefit before making an investment. Evaluating the impact of AI on student outcomes. Evaluating the effectiveness of AI. It's intentional to assess the impact of AI on student outcomes and identify which areas need improvement. Proper evaluation of AI systems is crucial to achieving optimal results. Resistance to change. Many educators may resist the use of AI due to a lack of understanding of the potential benefits. Adequate support and training to help stakeholders understand the potential benefits are necessary. Personalization and ethical concerns. AI-based personalized learning system can improve outcomes, but also raise ethical concerns, but fairness and equality in education. Institutions need to ensure that AI systems do not create learning bias for certain student groups. Building a robust technical infrastructure. Internet connectivity. Reliable internet connectivity is needed to support AI systems and reduce downtime. Computing resources. Sophisticated computing resources must be available to maintain and update AI systems regularly. AI tools and resources. AI implementation requires organizations to have adequate resources like software and hardware tools to support the successful application of AI technologies. Collaboration. By collaborating with industry experts and leveraging the latest technological advancement, institutions can enhance their technical infrastructures to support AI systems more effectively. In conclusion, please let me to sum up the main points. Staff findings. Research method in AI-driven higher education, involving themes in AI research, challenge and barriers to AI implementations. Implications. The importance for stakeholders to stay updated, informed decisions on AI adoption and integration, addressing challenges and risks associated with AI. Future directions. Examining case studies of AI-empowered higher education. Explore perspective of stakeholders, students, educators, and administrators. Aim for effective, equitable, and innovative education solutions. There are still some issues and shortcomings in this research, and I sincerely invite all teachers to criticize and provide valuable suggestions. That's all. Thank you for listening.
All right. It's a this topic will also be very interesting to everyone because talking about AI used in the higher education. Any question about this research? All right.
Thank you very much for your presentation. And so from what I remember is that you said about AI application and AI research team that they are like in a pie chart and there are different types of researches. And how do you think that which AI researches will be more beneficial to the educational system? And what do you expect to exponentially expand in the future?
Thank you for your question.
Thank you for your question. And about research, we didn't get that even though quality and qualitative research and mixed method research, both are very valuable research method. And we, from literature review, we cannot see that which one is better or which one is benefiting the most. We can just see that from the trend of the literature review, we can see that the qualitative research method is getting more and more, and maybe that's an indication for us that we want to go deeper in the research of artificial intelligence in education. We may consider that using qualitative research may be a good choice. And thank you for your question.
I suggest you can use a theory called technology infusion theory to support your research framework or your interview questions. I think this paper can feature conduct as experimental study, not only literature review. And I believe this topic will be very interesting to every readers how to that AI can be implemented in higher education. Like myself, I also conduct a study about what did you use AI in, prepare your PPT, or you ask the ChatGPT to translate some kind of document for you, and or just for fun or something else. You can find in what kind of usage is more popular. Maybe in different countries have the different results. So then we can do some kind of comparative study about the usage of the AI in university students. All right. So I think anyway, it inspires us some kind of research topic. We can do it. All right. Okay. Then we'll go to the last one. Is that right? Okay. The last one should be the fourth one, but thank you for your presentation. All right.
Thank you, everyone.
Mustafa. Okay.
Good evening, everyone. I'm presenting on a small-scale experimental study we conducted and the topic is, does gamification influence students' online learning behaviors and academic performance, a learning analytics perspective? So basically, we are looking at how gamification, which I will explain, affects the online learning behavior of students and also their academic performance. And we did that using the learning analytics perspective. So why were we motivated to conduct this study? A lot of studies have been conducted in this area, but very few are focused on the changes that gamification itself can bring to students' learning behaviors and what it means for their academic performance. So we try to conduct a study in this area, and we use the learning analytic approach, which most of us know, and I will also briefly touch on that. So it is undoubtable that many higher education institutions now are making use of groundbreaking technologies or digital technologies to reinvigorate their forms of teaching. And one way that they do is using learning management system. And we find this approach or method during e-learning that we have, and also in distance education. And we can attest to this, that during the pandemic, e-learning became a norm, and many institutions made use of learning management system. Those even in developing countries who were not accustomed to these practices had several forms of learning management systems. Maybe they are differential learning management system, but they made use of learning management system in order to ensure the continuity of education. So learning management systems are generally used by education institutions to provide learning content to students, as I mentioned, especially for distance students or in some open universities, or for people where we have a digital environment or a technology enhanced form of teaching or learning. So many universities make use of learning management systems, but the problem is that from my area, especially in some developing countries, many students have difficulties accessing learning materials on learning management systems. So because of the glitches in learning management systems in some countries, the intended purpose are not achieved. So we try to highlight that the potential of learning management systems have not been fully realized, and we can do that using learning analytics approach. So what we did in this paper was to gamify a learning management system that was already in existence. So we call that the traditional learning management system, which is available mostly in almost every institution. So we gamified that learning management system, and I will explain the gamification aspect of it. And making it in a unique way, we hope that by the gamification approach, many students will be more attached to the learning space, and also it will improve their academic performance. So we created a system that improves student engagement and promotes their learning activity on the learning management system. So this is the interface of the gamified learning management system that was created. So the assumption or the initial hypothesis is that the gamified learning management system will be better in terms of improving student performance or their behavior, learning behavior on the platform as compared to traditional learning management system. So we focus on two main questions. What are the design elements? So what did we use to gamify that learning management system? And also, what's the relation or correlation between the gamified learning management system and the academic performance of students. So gamification is a concept that is not new. Basically, you are applying the design principles of games into learning or any activity that you want to gamify. So intrinsically, many people, they want rewards, they want to achieve or self-actualize. And as we play games, we are competing with people. We want to accomplish or finish the game. So these game rules are being applied in the education arena to ensure that students, by competition, healthy competition, they are able to engage in learning and also improve their learning. And this also helps in self-directed or independent learning. So we have the game mechanics and also the game elements that are being applied. So the mechanics and the elements are the features of the game, including the rules, feedback, and all the activities that occur. And because education or learning itself is not a game, when you applied some of the principles of gaming into education, we call it identify that learning situation as a non-gaming context. So several studies or researchers have highlighted that gamification have an effect on academic performance. So we can reference from this study, like Oliveira et al. They found that 80% increase in student motivation and further significant relationships were recorded between student profiles and the results and their results when gamification was incorporated in learning. And the same results were obtained by the other researchers being highlighted on the screen. And for any form of learning, feedback is very important, and there are different forms of feedback: the summation feedback, the direct feedback, the formative feedback, and indirect feedback, different forms of feedback. And we find that these are very essential to learning. So in any learning management system or e-learning form of studying, the teacher or tutor has to give feedback, and sometimes there is even peer feedback. So in gamifying the learning management system, the authors also sought to gamify how feedback is produced. So the gamification was integrated into all aspects of the learning management system. And learning analytics, which is also not new, basically try to collect data from a learner or a student and then analyze it, interpret it, so that from the evidence that is gathered, teachers or educators or school leaders will be able to improve the learning experiences of students. So it's basically taking data like big data or any form of data from students and monitoring their progress. You are able to improve their learning in terms of their behavior or engagement or academic performance. So basically that's what learning analytics focus on. So it provides evidence-based insight into the learning of students or any learner, and then leaders or teachers will be able to use that to improve their performance. So with gamification, learning analytics plays a key role. So when the learning management system is gamified, learning analytic approach helps in collecting data to see that if the gamification approach that was adopted was effective or not as compared to traditional learning management system. So the experimental approach was that there was a traditional learning management system and a gamified learning management system. And using learning analytics, we wanted to see the progress of students in the traditional learning management system and also in the gamified learning management system. And then we see if we gamify the traditional learning management system, there was an improvement in terms of academic performance or learning behavior. So as I talked about feedback, learning analytics has been highlighted to play a very key role in terms of providing feedback, that it offers significant practical support for feedback practices, and also it's an essential component of feedback design in data-rich environments. So the method is what I just mentioned. Basically, it's an experimental approach. There is a traditional learning management system that was gamified, and we want to use learning analytic approach to know if the gamification of the learning management system, the traditional one, led to improvement in students' performance. But in doing that, we use also a theory called the self-determination theory by Deci and Ryan, which most of us are very conversant with. And this focuses on the intrinsic or innate abilities of a learner in terms of their competence, autonomy, or relatedness. So this theory puts forth that all of us have a desire, an innate desire, and when it is stirred up by a teacher relating well with a student or giving them a sense of autonomy and also making them competent, they are able to improve intrinsically. So by gamifying the learning management system, we wanted to include the psychological aspects of the learners, how it can improve their autonomy, their competence, and a sense of relatedness. So 204 students form part of the study, and 100 were put as a control group, which is group B, and 104 was the experimental group, and this group were the people who learned using the gamified learning management system, while the control group used the traditional learning management system. So this is how the gamification elements or the game elements relates to the SDT theory, which is competence, autonomy, and social relatedness. So the gamification elements are points, badges, leaderboards, levels, and feedback. So in including this, we were focusing on enhancing the competence of the learners. And we had also avatar and customization badges. In doing this, we wanted to also enhance the autonomy or promote or encourage the autonomy of the learner. And also, there was a forum discussion, and by doing this, the learners have a sense of relatedness or belonging to the tutor or the learning management system. So these game elements are explained here. So activity point, if a learner learns on the learning management system, which is gamified, they get points, and when they get points, maybe they want more, and it helps to improve their learning. And also badges are given to people or learners who interact on the gamified learning management system. So most people also want to complete assignment, perform their tasks, and get badges. And leaderboards help them to track their progress. They can also look at the progress of their colleagues, and this is like a form of competition which we see in games, and this helps them that, oh, my colleague is performing, I also have to perform. And levels show the activity levels, and they want to up their levels, and this are all game design principles. And I talked about feedback, avatars, and discussion forums. So all of these are incorporated as part of the gamification. So the intervention is what I have already mentioned, and the teacher uploaded lectures in the gamified learning management system in the same way as the traditional learning management system to prevent any bias, and this was done for 2 weeks, and points were calculated in order to arrive at a result. So most using the learning analytic approach, you want to get data from the students. So the students who log in, the records are taken, the lectures they viewed, understanding that they depicted in terms of a particular lesson, pages they visited, messages they read, profile change when we talk about the avatar and customization. So all this data are collected, and from the results, it shows that the logins, the views during the gamified learning management system, it increased as compared to the traditional learning management system. So when we gamify a learning management system, there is an increase in the views. Many students will log in to participate in the learning. So if we draw a line, you will see that the part B, which focuses on the gamified learning management system, the login or participation increase as compared to the traditional learning management system. And just a Pearson correlation between their understanding. We are looking at how it affects their performance. So we use their understanding, which was collected using the learning analytic approach, and we got to know that based on their understanding and their grade points, there was a positive and significant correlation between these two. So it means that an increase in their understanding scores mean an increase in their grade points. So in conclusion, we are just saying that learning management systems have potential, but they are not fully tapped. And if we use gamification approach, we can enhance the learning of students. But there were limitations also in our study. This was developed, and any system that is being developed is not perfect, so it can be enhanced. And also, we should have also presented the scores of each of the game elements, but these were not presented yet. But this is just a preliminary study to a larger project. So this is what the entire study is about. When we use learning analytics to gather data from students, policymakers, school leaders, and all stakeholders, relevant stakeholders can use it to improve the learning of students. So thank you.
Okay. Gamification. Okay. I think a lot of students play game, but gamification is something different from game-based learning. Anyway, there are many types of the gamification. So do you study that? Many types of the gamification.
I wish my co-authors were here too. But one expert is here. But
all right. So which you study, you can develop different gamification style and strategy, and to see what kind of gamification is better for what kind of subject and for students to learn. Okay, another question. Okay, I think that lots of work is a good job. Yeah. All right. If nobody want to ask any question, then we will be the end of here. All right. And to the chair, I think just can propose if somebody interested in what kind of topics, maybe we'll talk about a lot of feature study. So you can cooperate together to do some kind of comparison in different like gamification or like technology, AI infusion to students or teachers to compare study. I think that's the more interesting. So because we have students from, we are presented from Vietnam and from Malay. Yeah, you're Malaysia, okay. And from China, and like myself from Taiwan, and the other people I think show up here. And if you are really interested in some kind of topic, I think we can do some kind of topic for some kind of country get together. All right. So we ended before time. That's the best one. Any other question? You can communicate each other Later on. Okay. Thank you, everybody. Thank you. Okay.